Good morning, Jefferson.
Good morning, sir. This isn't your usual mug, is it, sir?
No, it's not actually.
Double boost.
Yes, the pseudonym and channel page of one of the UK's most popular YouTube machinists, the infamous John Mills.
Marvellous. Trusted Engineering, is that a place?
I believe more a combination of some common engineering terms.
Ah, very good, sir.
MrCrispin here once again, and welcome to my workshop. In today's video I'm going to be showing...
Oh, sir, would you be in for your 5 o'clock sherry?
Yes, thank you, Jefferson, that's a nice idea. I'm going to be showing how I went about making 3 of these. Now, I'm not going to be discussing the design concepts or why they look like this. If you're interested in that, have a look at the video Regrinding a Chuck. Today's video is all about how I made them. Now, in a modern tool room, I would expect this to be wire EDM'd. That's wire electro discharge machining. Imagine a cheese wire. You come in with a wire electrode and it can cut out a profile in any material that conducts electricity. That is how I'd expect it to be done in a modern workshop, run by a program, and it will just come and do it. In this workshop it's going to be milling, and even having picked milling, there's still a few options. For example, I could come in with a small cutter and interpolate out a rectangular pocket and then maybe rotate the component and feed along the angle. Or I could cut out a pocket and then in a different setup come in with the side of the cutter to machine the angles. Either way, I would be doing a lot with small cutters and I would be left with some amount of corner radii material, which may or may not be a problem depending on the exact dimensions. What I'm actually going to do, however, is use a method that allows me to use slightly heftier cutters, and I'm going to, having roughed the middle out somehow, I'm going to turn it on its head and use a different type of cutter to come in and produce these angles. Now, what kind of cutter? Well, thankfully Jefferson has prepared a few examples earlier. These are forms of dovetail cutter, and imagine if I could come in from above with a cutter that would produce a 30-degree angle. Well, maybe someone out there has a 30-degree cutter, I'm sure they exist, but a more standard dovetail cutter is 60 degrees or 45, neither of which give me the 30. So what I'm going to do is use a 45-degree cutter and introduce the topic of sharing an angle. Now, this is actually something I've done quite a bit of in grinding. Let's say you need to produce a steep angle, but you don't want a steep face on the wheel. What you can do is share the angle and put some of the angle into the wheel and get the remainder of the angle by chipping the component. And that's exactly what I'm going to do in today's milling example. I've got 45 degrees on the cutter, and so to get my remaining 15 I'm going to tip the component. So the cutter will be presented and the components relationship will be tipped to give me a resulting 30 degrees, and you'll see how that comes to play on the milling machine shortly. Now, even having established that, there's still options, because do I tip the spindle or do I tip the component in the vise, perhaps by putting a 15-degree angle underneath it? Well, putting an angle block under it in the vise is certainly the quicker option in terms of resetting the machine and not having to disrupt the machine's spindle alignment. However, it does have an inherent downside, and that is whenever you put an angle block under a component, you lose your reference surfaces to some degree. When that component is square in the vise, edge finding and picking up on faces is easy because the planes are all aligned with the machine's axes. As soon as you stick a angle in there, you're very limited on what you can touch off on. Maybe you could use an external corner at a push, but you have certainly caused yourself more complexities. So what I'm going to do is I'm going to keep the component square in the vise and tip the spindle. So just explaining a few bits there so that as I go through there's not too many questions arising. Now with all that said, let's make a start. Here at the Deckel FP1 I am ready to start milling. I have taken the workpiece and given it a quick file up, and following that I've taken a parallel and a Z-square and squared the component within the vise. I will now take a quick facing cut on the two sawn faces, and from there I will proceed to rough out the centre stock removal portion. I have set by feel the top of this cutter to be level with the top of the workpiece, and I'm now going to zero the dial and move down 5mm, which will give me the thickness of the end chunk that I'm after. Now I'm going to start at the top and work down so that I get the maximum support. If I was to start at the bottom and work up, I would be continually weakening the wall section and perhaps getting more vibration as I went up. So I'm going to start at the top and go down. Now both sides of the cutter are going to be doing a similar thing in this scenario, so this isn't climb or conventional milling, this is what's known as neutral milling. So just because I can, I'm going to start at the front, and so you should get a better idea of what's going on with the cutter. I'm eager to find out myself, and with that said, let's have a go. Right, with the aid of my brother's toothbrush you can now see the finished effects, and that is that I've created a square-sided channel. Just by means of finishing off, I'm going to step over 0.25 of a mil 10th thou this way and come back up this side, and then step over 0.25 of a mil that way and go back up that side, and I shall do so in a climb milling motion. Cleaning up of the side walls has now been completed, and that brings the end to work with the T-slot cutter. Moving on, I'm going to produce the two angles required, and as mentioned earlier, I'm going to do so using this 45-degree cutter and 15 degrees with the angle of the spindle. Now, a few things to mention ahead of this operation. Number one, there's two different approaches I could use here. One would be to offset the spindle 15 degrees this way, do the machining, and then offset the spindle 15 degrees the other way. And if this was a particularly complicated setup with lots of clamps and clocking in, I would probably tackle it that way. But because this is a simply held component in a vise, what I'm going to do is machine one side and then flip the component and do the other side, leaving the spindle set at the same angle. Now fortunately, the way this has worked out, both this dimension and the same one on the other side have ended up within about 1/10 of each other. So what I can do is just set a stop machine one angle, zero all the dials, rotate the component and then work to the same numbers, and that should give me a good level of precision right off the bat. The second point to mention is, how am I going to get the spindle to 30 degrees? Well, for the level of precision required and the length of angle I'm dealing with here, use of the protractor with some magnification will be perfectly adequate. Again, if this was more complicated and more precision was required, I could use either a sine bar or a 30-degree reference angle and then tram the head in using a clock to get a much more precise setting. So that is how I'm going to proceed. The first thing to do is tip the head, and on the decal that's done by means of 4 cap heads round the back. Make some minor adjustments. And re-snug. It is now time to proceed with the angled milling operation. So first of all, it's just a brief clearance check. As you can see, the cutter is able to pass through there with this side remaining in clearance, which is the important bit. Okay. So what I'm going to do is I'm going to touch onto this side using a piece of cigarette paper, and then I will back off maybe 2 thou, 50 microns off this side so that this wall is remaining in clearance, and then I will just continually drop the table so that this corner is fed into the 15-degree angle that I have set the head at. Coolant off for now. So first job is to just set my X position. Now with a cutter like this, it's going to just touch on a corner. I might not get much reaction on the paper. Oh, there we are. Keep an eye out. Right, so I'm just going to go back the way 50 microns to give myself some clearance. So feed away and back in to stand me off 2 thou. Okay, and now I'm going to bring the table down and that has just made contact there, so I can now start machining this out. Final inspection of these angled faces is being done by means of a simple dowel method. So there's a slip gauge there, and the principle here is that the higher up the angle is, the further towards this face the dowel sits. And so by checking here and then here, I can see if the two angles have a similar relationship to the outer block. So I've got them now within half a thou, both sides matching. So that concludes everything that can be done in this setup. The component is well on its way now, and there is not a great deal more to do before I split it into 3. Now, having set the head at an angle, I need to re-establish it to its perpendicular position. Often if I'm doing any angled head work, if it's just a few features like here, I leave the angled head work till last. Then I can finish the component, strip the machine down, take the vice off, clean everything and reset the head to the bed. In this case, however, I will have to finish off by remachining the flat faces following the sawing operation, so really it didn't matter if I left the angled work till the end or now, I'm still going to have to reset the head. So what I'm doing this time, I'm leaving the vice on, I've put a parallel in there, checked it with a clock, and I'm going to use this parallel as my reference surface for resetting the head to perpendicular, and I'm going to do so using a gift I've been given by a kind subscriber who will remain anonymous, and it is a spindle square. So I'm going to use the spindle square on this parallel to regain perpendicularity of the head. I have reset the protractor to 0 using the loop, and now with the spindle square brought over the parallel I'm going to calibrate it. So the procedure for this is to bring the table up until I get a 0 reading on the dial. Okay, check that repeats. And now I spin this to 180 degrees, and reading from the other side of the machine, I now set the dial to read 0 by moving the bezel rather than by adjusting the table. And with that procedure completed, what I now do is bring the whole table up, and if both dials read 0 then the spindle is trammed perpendicular. There's a small error, so my adjustment bolts loose, I can bump the head. And what you want, of course, is the needle the same. So I now have a 0, reading, and as long as this head doesn't move whilst I do the bolts back up, I will have regained perpendicularity. The final milling job before I split the component into 3 is to put on the external corner radii, and to do this I will touch on to the side wall and then feed upwards with the table until I get a nice blend both sides. Sawing through the component horizontally. This is a rather tricky piece to hold with the standard work holding arrangement for the bandsaw, so as you can see I've put a vise in a vise, and I will cut through until the blade reaches somewhere around the top of the jaw, then I'll finish off with a hacksaw. First cut, you can see what the bandsaw did, and then you can see what I hacksawed. Now I could go ahead and saw the other piece, but if I was to do so at this moment I would be left with a middle piece that had a sawn face on both sides, and therefore a piece with no reference surface, and so re-establishing squareness to the existing edges would be a little tricky. So whilst I've still got this reference surface, I'm going to put it back in the milling machine, take a quick skim on this face and re-establish a square, and then put the second slit in, leaving me with 3 individual pieces that all have a reference surface. All the reverse sides have a milled face, and I will now proceed to take all these to the same thickness. So following various stages of work, all the holes are now in, tapped M4 in the underneath, and that leaves these components just about finished. Sorry, won't take me long, just couldn't help giving these parts a quick flash up. Following the various stages of manufacture, the completed jaw dollies can now be seen, and what you will be able to observe is that I've installed an M4 grub screw into each of them. Upon locating these on the shock jaw, I will put in the M8 dowel into the reamed hole, and following that I will clamp the clamping ring and proceed to grind the jaws. So to finish off, I will leave with a few clips of these in action. So the hook portion of the jaw dolly slides over the angle, and then through means of a grub screw that is going down the middle, I can clamp the jaw dolly on such that it's hanging on those angles. I have of course made 3 of them, so if I just position these in position, I will then complete the demonstration. Ring. And now I can clamp the ring. The chuck is being closed in a forward clamping motion, and the clamping is going on at the front of the jaws to give me the right kind of clamping bias. This of course allows access for the grinding wheel to go up and down the middle, as the jaw dollies and ring have left the key surfaces exposed. And a close-up alternate view of the jaw dolly clamping system can be seen here. That is all the jaws now fully reground. Okay, checking down the bore. I am 2 6/10 past 0. The dimension of course is irrelevant. I'm just taking a reference. And down here 2 4/10 past 0, so there's 2/10 of a thou, around about 5 microns difference front to back, which is highly acceptable. Okay, so that concludes grinding of the bores. In total that was a total material removal of 120 microns, which you're getting on for 5 thou. 7 passes with spark out passes to finish. Whilst it's situated like this, I'm actually going to come in, and in fact this ring will work fine. I'm going to come in and I'm going to grind the faces of the jaws to give me a nice square reference. Right, well that's quite enough for one day. Sherry o'clock is quickly approaching. Now 2 things to leave you with. Number 1, go and give John Mills some support, double boost. I've put a link to his channel down below. Good to see a fellow UK YouTuber doing well. And second of all, even if you have already seen the regrinding a chuck video, I recommend going and having another look, because the comment section on that video was first class and there was a lot of very good insights from people with a lot of background information. So those are 2 things for me to finish on. Apart from that, thank you for watching. I hope you found this interesting, and see you on the next video.